we are looking at notes 3.4, which are on solving rational equation word problems. We've already talked about solving rational equations, and we've even done word problems if you remember, we had an example with t-shirts. So I just want to go over 2 more word problems, and then we should be good to go for this lesson, for this topic. So it says salt water is flowing into a large tank that contains pure water. The concentration of salt C in the tank at t minutes is given by this equation right here, where C is measured in grams per liter. When does the salt concentration in the tank reach 3.75 grams per liter? Well, first thing I want you guys to notice is that it's going to level off at 10 over 1. So at 10, it's going to try to reach 10, but it won't be exactly 10. That's where it's going to try to approach. Regardless, we want to know when it's going to be 3.75. So I want to know when C is going to be 3.75. Now, one thing we have to make note of is that T cannot equal negative 25. But that doesn't really matter, to be honest, because if T represents time, we can't have negative time. So every time I see a C, I'm going to replace it with 3.75. So I'm going to say 3.75 equals 10t over 25 plus t. Now we learned that to get rid of this denominator, I can just multiply both sides by 25 plus t. So when I do that, I have a 3.75 on the outside times 25 plus t, and I also have that these t's will cancel each other out, so I get 10t. Sorry, these expressions will cancel out, so I get 10t. Now it's just a linear equation that I can solve. So I'm going to distribute the 3.75 through. When I multiply 3.75 by 25, I get 93.75. Plus, when I multiply 3.75 times t, I get 3.75t equals 10t. Now I can subtract the 3.75t from both sides right here. So I get 93.75 equals 6.25t. And then I can divide both sides by 6.25. And that would give me t equals 15 minutes. So it would take me 15 minutes for the concentration to reach 3.75 grams per liter. Okay, and I'm good to go for this question. All right, number 2, when they work together, Stuart and Lucy can deliver flyers to all the homes in their neighborhood in 42 minutes. So that's key. When Lucy works alone, she can finish the deliveries in 13 minutes less time than Stuart can when he works alone. And I want to figure out how long does it take Stuart to deliver the flyers. So the first thing I'm going to do is I'm going to identify what I don't know. And I don't know the time it would take Stuart to deliver the flyers. So we're going to say let Stuart's time equal t. Well, if Stuart's time is t, then we can write an expression for Lucy's time. And it takes Lucy 13 less minutes, so we can say it's t minus 13. Okay? Now, we've got to write some other information down here. So in 1 minute, what's happening? We know that Stuart is getting 1 over t of the job completed, because we know that it takes him t minutes, so in 1 minute it's 1t of the job. Okay, we know that in 1 minute Lucy can complete 1 over t minus 13 of the job, because again right here it takes her t minus 13 minutes to complete a full job. Okay, and then together we know that they can complete 1/42 of a job, because it takes them 42 minutes just in order to complete the job. So what I'm going to do is write this out as an equation. Okay, so I know that right here we can say that if I combine Stuart's minute and Lucy's minute, or the amount that they can complete in 1 minute, it's equal to the amount that they can complete together in 1 minute. Okay, so this right here is going to be my equation. Now I have to find out what my LCD is. And remember, our LCD, if there's nothing in common with any of these terms, then our LCD is going to be 42t times t minus 13. Okay, so I can say my LCD is 42t times t minus 13. So I'm going to multiply everything through by 42t times t minus 13. Well, the t's cancel out right here, so I end up getting 42 times t minus 13 left over for my first term right here. For the next term, I can say that this t minus 13 and this t minus 13 will cancel out, so I've got 42t times 1 left over, or just 42t. Okay, and then for my last term, I can say that this 42 and this 42 cancel out, so I'm left over with t times t minus 13. Now I have a quadratic equation that I need to solve. So I'm going to distribute the 42 through, so I get 42t minus 546 plus, just copy down the 42t, and then this t right here, I can distribute this through, so I get t squared minus 13t. Okay? On the left side, I'm left over with 84t minus 546 equals t squared minus 13t. Okay, now bring everything over to the right side because we want our t squared to be positive. So I get t squared, and then negative 13t minus 84t is negative 97t. And then when I add the 546, this becomes positive 546. Okay, so now when I factor this, I'm going to look for two numbers that multiply together to give me 546 but add up to give me negative 97. And those two numbers are negative 91 and negative 6. So therefore, t would equal 91, or t could equal 6. Well, now that I've figured that out, one of these answers is actually inadmissible because I can't have 6 minus 13 minutes. That will give me a negative value, right? So this right here is going to be inadmissible. It's not possible, which means that t has to equal 91. So that means that Stuart's time is 91 minutes, and Lucy's time would be 91 minus 13, so she would have to take 78 minutes, okay? So now let's just double check to make sure that this really works for us. So if I figure out 1 over 91, and I add 1 over 78, I should get 1 over 42, which is exactly what I get right here. So that means that we did it correctly. So we can say, therefore, it takes Stuart 91 minutes to deliver the flyers alone. Okay, and that's all we have for today. I'll see you next time we have class. Bye.